Yourself a cone. It's very difficult. Okay, but here's how you can do it. I'm gonna show you how to do it. Okay. Here's what you do. I'm gonna talk about 4 conic sections and where they come from, and they're all stemmed off this idea of drawing from a cone. So here's what you can do. Okay, so you can draw a cone looks like this, go down on both sides. Ooh, that's bad, messed up there. And then bring around the front, and then what you can do is this sort of 3D image. You know, if you do a little dashed line in the back. Okay, so we're talking about conic sections, and have you heard of that term or before, conic sections, anywhere in your life? No, you haven't. Well, you've actually studied one of them in detail before this class, and another one in part detail in this class, and then 2 others we haven't yet got to yet. Think of anything? Can you think of one? No. Okay. All right. Well, have you heard of a circle before? Yeah. Well, then you've heard of a conic section. All right. So let's talk a little bit about a cone for just a second. Cones have bases, right? A base down below here. The top part is called the vertex of the cone, and you can have an axis sort of in the middle here. Now, all these things are kind of irrelevant for right now. They're just points of reference for us, because the really cool part is taking this thing called a cross section. Have you heard that term before, cross section? Where have you heard that term before?
Biology, like cross-section of a pea plant.
The cross-section of a pea plant, and when you cross-section a pea plant, what are you looking at?
Dominant recessive alleles.
Yeah.
Homozygous alleles.
Also in biology, like a cross-section of a cell, so you're cutting it in half and looking at.
Does it have to be in half, is my question, for it to be a cross-section? It doesn't have to be in half, right? It could just be a sliver anywhere along the figure that you're looking at, right? So, for us, if we take a cone, and we take a look at a cross-section of a cone that is exactly parallel to the base. Here's what it looks like, okay? Sort of, and then like behind the cone back there, and then come out, right? A cross-section. The figure that is created is that of a circle. So you can create a circle from a cross-section of a cone. So therefore, a circle is one of the conic sections. A circle. That's our first one. And that one you should have studied a lot in detail in geometry. So a circle is one of the conic sections. Okay, there are 4 of these, so I'm gonna go through each one. So again, I'm gonna draw my cone here for emphasis. Go back, put an axis in the middle, make it perpendicular to the bottom. Okay, and if you take that cross section and you sort of tilt it on a side, so here, so if it looks like this, if you tilt it up on a side. That's okay, don't worry about it. Okay? If you tilt up on the side, the figure that's created from the cross-section is elliptical. So you can actually get an ellipse from a cross-section of a cone as well. So an ellipse is our second conic section. And the ellipse? Yeah, it's a cool word. So far we have circles that we can get from a parallel cross-section to the base. We have ellipses if we sort of tilt our cross-section up a little bit. The third one that we can get is a parabola. Anybody see how we can generate a parabola out of this thing? If I have to use a cross section now, so what can I do to create a cross section that would give me a parabolic shape? Anybody see it? On the base? What do you mean on the base? Something to the base. Dude. Yeah, vertical, like, or like perpendicular to the base. Yeah, exactly. So if we did something like this, okay. Okay, the shape that sort of ends up being on the front of this, right here, is parabolic. So you can actually get a parabola from a cross section of a cone. So that's our third one, parabola. And that's the one that we're going to start off with learning about tomorrow in great detail. So the parabola. The fourth and the final one comes from putting 2 cones on top of each other with the vertices matching. Yes.
Don't you get a triangle though? Can't you get a triangle? We're just going straight down the middle vertically?
Yeah, you sure can.
That's not one of them though?
A triangle's not a conic section. If that's what you're asking.
Why not?
What's that?
Why not?
Oh, because the base is curved. The cone's open at the bottom.
Like a funnel.
Yeah, like a funnel. Yeah. Yeah, like a funnel. There we go.
It's no cone holder. No, it's a funnel.
Well, I think both of those work. Nice job, guys. Here's the other one. Okay, if you take a big giant cross section that goes up through both of these here, okay, what you create in this case is called a hyperbola. Not a hyperbole, but a hyperbola. All right. So the fourth and final cross section is called the hyperbola. So we have circles, ellipses, hyperbolas, and parabolas here. And what I want to show for you, I've got this. I have this video that I found that actually goes through and shows these. So I would like to show this video to you, and then we'll come back just a second. This is the one I want right here.
Why'd you search nuclear reactor?
Oh, I'll show you in a second. Hey, make this thing bigger. Oh, there we go. Here we go. Okay, so here again are it's kind of fuzzy, but here are the sort of the four conic sections that we have. And check this out. As you tilt this plane, as you this pretty. So they got circle there. You get the circle, and this one does this, gives you the figure on the plane as it's rotating back and forth. How cool is that, right? That is pretty cool stuff, right? So there's some two videos I found for you there that I want to share with you. So here's we're gonna do some search, but I want to guide. Okay. So I want you right now. Can you think of 4 applications of the first conic section that we talked about, the circle? All right. It's a pretty easy one, a pretty awesome one. That if we didn't have, I'm not sure life would be the same. Can you think of 4 applications for a circle? Give me one of them off the top of your head. The wheel. There you go. That's the one I was thinking of. Without the wheel, man, I'm not so sure if we'd be the same. Anything else? Yeah.
Plates.
Plates. There you go. Can plates be not circular?
Donuts.
A plate. Donuts. Thank gosh we have donuts. Yes. No. A hula hoop. How do you spell that?
Thank gosh we didn't do it. Same thing.
Hula hoop. There you go. Okay. An application. Another application for circles. Pizza pan. You guys are right on food. There you go. Okay, good. So, can you think of more applications for these things, Sarah?
Frisbee.
Ooh, good. Okay, here's an extra credit question.
Basketball.
What was the original name of the Frisbee before Whammo bought it and named it the Frisbee? Look it up. Look it up and bring it back. Oh, so pie. Good, okay. Good. Okay, well, give me one more application for the circle. Earth. What do you mean by that? Okay, so a clock? Hey. Okay. Yeah, I know. Okay, let's come up with what you found for the parabola. Applications for the parabola. Yes, give me one.
Roller coasters.
A roller coaster, like
Yeah,
Okay, good. Good. What'd you come up with?
It's roller coaster.
Oh, sorry. What? A satellite dish. Okay. Yes.
3-point line.
Yeah, I'm not so sure about that. We'll look that one up. Really? You guys think so? Okay. Well, yeah. Let's see. Yes. What do you mean by that? What do you mean by the bridge? Like a suspension bridge? Like a part in the middle? Okay, good. Like the Golden Gate. Okay, good. All right, let's hear. Let's look up a 3-point line together.
Or a smiley face. Like, send a smiley face to your girlfriend on text. It's like,
Okay, let's hear. 3-point line. Let's see here.
he has the right basketball.
Yeah, I looked this up last time, and we came to the conclusion that this wasn't exactly.
How is it not that?
It wasn't exactly. Well, it didn't work out to me that way.
Are you still recording?
Yeah, I know. It's fine. Yeah, it's really slur right now.
Oh no, what we should do is we should get a picture that has a picture of the high school one, the college one, and the pro one, so that you can compare and see which one is more like a pro. You gotta swap it. It's your turn. Okay.
So what we did was we took a look at this image right here, and if you look at it, I'm not so sure those are parabolic in shape, right? I mean, I think maybe more semicircle out to here, and then it sort of flattens out as a line. I don't think that's exact parabola though.
Oh god, that's a crude drawing.
How is it not?
Yeah, I'm not. It's close.
But what is this? Is this high school or is this like?
Yeah, it depends on what.
Yeah.
So you mean to tell me that in any level of basketball, this part changes at the end here?
Absolutely.
No, go back.
Check out NBA 3-point line.
Yeah, go back and then go to the first. Because the first two were like had a, yeah. There you go.
This one right here.
Yeah, there.
So these are all different.
Yeah.
Okay, so are any of those parabolic?
The dotted. Yeah, the dotted.
Are those parabolic or are those semicircles?
Dotted ones is.
The dotted is. Look at the dotted. The dotted one.
So okay, so my question is, or not flatten out. Like because it doesn't flatten out, does that automatically make it parabolic? Okay, so it has a certain shape that's similar. It may or may not exactly be, but